half cell potential. Voltage developed at an electrolyte interface is known as the half cell potential. This is an electrolyte interface. It consists of both positive metal ions and negative ions. We are measuring the potential difference over here. Electrolyte characteristics. First one is perfect polarized electrode, and the second one is perfect non-polarized electrode, and the third one is artifacts. What is perfect polarized electrode? The charges are not transferred across the metal electrolyte interface. That is known as the perfect polarized electrode. Perfect non-polarized electrode, the infinite charges will transfer. Artifacts means non-polarized electrode will create variable noise is termed as the artifacts. Perfect polarizable electrodes. Electrodes in which no actual charges crosses the electrolyte interface when the current is applied. This current across the interface is a displacement current, and here the electrode behaves like a capacitor. Here over potential is due to concentration. The example for the perfect polarizable electrode is platinum electrode. Here the perfect polarized electrode is, as it behaves like a capacitor, the symbol is noted like here over there, like here. Perfectly non-polarized electrodes. Electrodes in which the current passes freely across the electrolyte interface. It requires no energy to make the transition. These electrodes see no over potentials. Example, silver chloride electrodes. Silver chloride is used in recording, while platinum electrode is used in stimulation. Polarization. If there is a current between the electrode and the electrolyte, the observed half cell is altered due to polarization. Over potential is difference between observed and the zero current half cell potentials. Over potential, resistance, concentration, and the activation. What is resistance? Current changes resistance of electrolyte and thus a voltage drop results. Concentration is nothing but changes in the distribution of electrons at the electrode-electrolyte interface. Activation is the activation energy barrier depends on the direction of current and determines the kinetics. PP is, the polarization and impedance of the electrode are of the two most important electrolyte properties to consider. That is, over potential is equal to resistance plus concentration plus activation. Types of electrodes. There are three basic type of electrodes. First one is microelectrode, near or within, it will be available near or within the cell. Skin body surface electrode, EEG, ECG, potential from surface of the skin. Needed electrodes, which as the name indicates, it will penetrate into the skin. Surface electrode. What is surface electrode? Surface electrodes are used to measure the potential available from the surface of the skin, as the name indicates, and to sense the potential from the heart and the brain. Surface electrodes we can categorize into two, depends on the area, and the second one is depends on the construction. Depends on area means smaller area surface electrode, and second one is larger area surface electrode. And depends on construction means first one is metal plate electrode, suction electrode, floating electrode, and the flexible electrode. This is the equivalent circuit of the surface electrode. In this circuit, EHC is half cell potential. This is device. R1 is leakage resistance, and C is electrode capacitance. RS is skin resistance, or C is electrolyte resistance. The half cell potential or voltage is expressed by the Nernst equation, which is the equation here. The parameters are determines gas constant, T is absolute temperature, which is measured in Kelvin, N is the valence of electrons, F is the Faraday's current, C1 and C2 the concentration of selected ion on two sides of the membrane, F1, F2 activity coefficient of ions on two sides of the membrane. Needle electrodes. This is the needle electrode. Through here needle electrode, how it is penetrated into the skin. It is shown in the figure. Needle electrodes are micro electrodes, measures potential within a cell. The diameter here is ranges from diameter ranges is mentioned over here. This causes no damage to the human cell. This is microelectrodes. The types of microelectrodes are metal microelectrodes and the micropipette electrode. Next one is measurement with the two electrodes. This is the equivalent circuit of biopotential electrode interface. We are measuring biopotentials of two electrodes. First electrode, second electrode. We are measuring the biopotential of the two electrodes. The voltage measured is the difference between the potential, the voltage how we are measuring, it is nothing but the difference between the potential of the two electrodes. The DC voltage due to difference in the electrode potential is called as electrode offset voltage. Two electrodes of same material may also produce small electrode offset voltage. Chemical activity takes place within an electrode can cause voltage fluctuation to appear without any physiological input. Such variation may appear as noise in the bioelectric signal. The noise may be reduced by proper choice of materials or by coating the electrodes to improve stability. Silver and the silver chloride electrode is very stable. The silver and silver chloride electrode is prepared by coating a pure silver with the silver chloride. This coating is done by placing silver into a bromide-free sodium chloride solution. A second piece of silver is also placed in the solution and the two are connected to a voltage source. Surface electrodes have an impedance of 2 to 10 kilo ohm, whereas small needle and micro electrodes have much higher impedance.